So day 3 of our two variable equations, simultaneous equations, whatever you want to refer to it as. The main thing here is we have our substitution method, we've got an elimination method. Again, big encouragement for the elimination method. And so what we're going to look at here today is one particular problem where, again, it's a little bit more frustrating because there's more action going on with it. And the reason why we tell you this is not because we're like handpicking frustrating questions, but there's always things you want to look for. Like, for example, when I look through this problem, the first thing I want to see is, hey, does any of the x terms fit into the other ones? Like, can a 4 fit into the 5? No. How about the 2y? Can the 2 fit into the 3? No. Because the benefit of that is then I can only multiply one row. And I'm like, yes, less work. So right now, I know I've got to multiply both rows by someone. And on top of that, they're all positives, which means I also have to multiply someone by a negative as well. So again, if you can plan ahead and know what you're getting into, even if it's got like work involved, it's a good sign that you know what you are after here. So yeah, I'm going to focus on the y's because those are the smaller numbers. So I'm going to multiply this entire top row, and I'm going to choose a I'm going to choose, well, it doesn't make a difference really. All right. Don't get too involved with, should I choose negative or should I choose the other one negative? No, just jump with it. If you get into the next problem or you get into the next step and you're like, wow, a negative wouldn't be really, then make your adjustment. Otherwise, just run right to it. Okay, so everyone's getting multiplied by -3. So I've got a negative 15x, I've got a negative 6y, and I've got a negative 36. Okay? Down below, I've got an 8x, I've got a positive 6y, and I've got a positive 22. So this is where you might have been like, oh, I should have multiplied that -2 and made it a positive 3, because now I've got more negative numbers. Like, I've got my opposites, goodbye, but now I got to do negative 15x plus the 8x. And if I had it the other way around, it would have been a 15x plus a negative 8x. Again, it's the same problem. I guess that's where we just kind of start to figure out comfort issues. Anyway here, we get a negative 7x, all right? Negative 36 plus 22, so how far away are the two? That's a negative 14, and oh, there we go, smile to our face here. Divide both sides by -7, look at that, a whole number. Oh, that's satisfying there. There we go, x equals 2. All right. So yeah, we can go ahead and plug that on in and solve for our y. So I'm just going to grab the first one. So 5 times 2 plus 2y equals 12, and we'll solve. So 10 plus 2y equals 12. Let's subtract our 10 from both sides. Hey, there we go. 2y equals 12. Divide, 2y equals 2. Yeah. All right. So y equals 1. All right. So, yeah. All right. So we can plug it in to check. I'm going to do some mental math. So I'm going to focus on the bottom one here just because I used the other one before. So 4 times 2 is 8. 3 times 1 is 3. 8 plus 3, 11. Got it. Check the other one real quick. 5 times 2 is 10. 2 times 1 is 2. 10 plus 2, 12. There we go. We're done. We got it. So again, the check step, definitely something encourageable. Again, it only took a limited amount of time, so it's going to be after. What we want to finish up with here today is just how to kind of ID whether we're going to have that one solution, no solutions, or infinite solutions. So one solution, all right, infinite solutions, or no solutions. So the idea here is one solution means that our lines are going to cross each other. They are going to intersect and they're going to meet at a point. All right. Infinite solutions means that they are going to be the same line. So you're going to have a line, and then it's like you're going to be like, oh, it's the exact same one, so it's touching it everywhere. Hence, that's why it's got infinite solutions. And no solutions is when we have parallel lines. So we got someone like this, and we've got someone like that, and they never end up intersecting with each other. So what we want to start to watch for is to start to see how we can identify some of these ahead of time. So when we look at an equation, what we're really focusing in on is the slope. Now, I'm going to put everything in slope-intercept form just so you can kind of see it, but then we'll show you how to kind of navigate it, because typically you don't see it in slope-intercept form. You're going to see it in that standard form with the x, the y, the equal sign, and the number that we're looking at. So 3x plus 8, and then let's go after 2y equals 6x plus 16. Now here, this is going to be an indication of we've got infinite solutions. They are the same line. And the reason why that is they're all being multiplied by the same number. So this entire equation got multiplied by a 2, and now it matches up there. So that's why it's the same equation, because it's being multiplied by the same number. So even if you see someone that's in that standard form, so 3x plus 5y equals 12, and then we see a 9x plus a 15y equals 36. Look, they're all being multiplied by 3, all right? So that tells me that it's the exact same line. So that's how I can tell right away. So again, something to be looking for, but not something to... It's a lot of times like I'll get the answer and I'll be like, oh, it's infinite solutions. Then I'll go back and look and be like, oh, there it is. Yeah, I see. They've all got the same amount that we're looking at. Okay, so let's look at some other ones that are in here as well. We can end up seeing someone like this, where we've got y equals negative 3x plus 8. And I'm also going to throw at you y equals, and then we're going to do negative 3x plus 2. And the idea here is if you visualize the graph, we're noticing they have the exact same slope. All right, which tells me that these lines are going to be parallel, and then we're starting at different points. So that's something to be aware of, and that's the whole idea of, oh, wait a second. Okay, same slope, all right, and different starting points, so that's why they'll never end up touching each other, which is why we're looking at a no solution. So in this particular case, what you're going to notice always is the x's and the y's are always the same. And again, we can set that up in standard form, but then that number off to the side is someone who's completely different. Yeah, that's when we're going to run into it. So if we take someone like 2x, all right, plus 3y equals, and then let's say 10, and then we take someone like 2x plus 3y, so again the exact same, but then a different starting point equals 15. Okay, these are going to be parallel lines that we're working off here, because again, of their x's and y's being the same and then being different, that's there. So again, something else to be aware of. And then the last one that we want to end up looking at is, how do we know if it's just a one solution? Well, these are the ones that you're used to. They got nothing that matches up, all right? They're just different across the board there. So if we notice before, we end up having sames, just the x and y's, but then those constants, that number off to the side was just different. And then we notice that, oh, wait a second, we also had with our infinite solutions, oh, we just multiplied, and then it's kind of everyone else. So again, it's something to look at ahead of time, but it's not something to invest a lot of time into. It's when you get something at the end, you're like, ooh, is it really infinite solutions? Then you can look back into it. All right, there we go, people. We'll see you later.